Hello children, as you are going to write the examination of SLC final year next month, so I am here to help you in preparing for the examination. And today I will take up the science question paper, and in that I am going to tell you about the important questions of physics. So first of all, to take up we'll go to the chapter electricity. So in this chapter electricity, so what are the important points and what are the important definitions that you have to learn that I am going to discuss now. So first of all, the first point is the Ohm's law. So this is very important. The question will be given to write the definition and also to write an equation also. So here, first of all, it is Ohm's law you should know. And for Ohm's law, this will be the statement you can write this. Ohm's law says that the current through a conductor between 2 points is directly proportional to the voltage across 2 points, or you can write across its ends also. Based on this statement, we can frame an equation, and the equation will be V is equal to IR. So here V is the potential difference, that is the voltage, and I is the current flowing through the circuit, and R is the resistance of the conductor. So this is the Ohm's law that you should know the definition and also the equation. And now let's go to the next important point, that is Joule's law of heating. You know that when a current passes through any material or any conductor, it gets heated up. So we are going to learn that how this heat is produced and how to calculate the heat by using Joule's law of heating. So here Joule's law of heating is like this. The amount of heat produced in a current conducting wire is proportional to the square of the amount of current. Square of the amount of current that is flowing through the wire, and when electric resistance of the wire and time of current flowing are constant. So this is the definition that should know. Based on this definition, we will get an equation with the points we can derive. We can come to the conclusion that heat produced in a resistor or in that conductor, if we denote it by the letter H, that heat is directly proportional to the square of the current for a given resistance. So the current is I, and so here, and then it is directly proportional to the resistance of a given current for a given current, that is R. Then directly proportional to the time for which the current flows through the resistor, and because it's time, we write it as T. So all these 3 points, if you combine, you will get an equation, that is H is equal to I square RT. So here H is the heat produced. To calculate it, so square of the current. So in the first point we have the square of the current, we have written there, and then into R is the resistance of that particular resistor, and T is the time for which it flows. So this is a very important equation. H is equal to I square RT. By using this, we can calculate the heat, or if heat is given and the time and resistance given, we can calculate current also. And if these 3 parameters are given, we can calculate resistance. And if these the other 3 parameters are given, we can calculate time. So here, based on this Joule's law of heating, we get this equation, that is H is equal to I square RT. Then we just move on to the next point, that is electric power. And this electric power is denoted by the letter P. Now let us see what is electric power. An electric power is the measure of the rate of electrical energy transfer by an electric circuit per unit time. So this also can be stated as this, like this. Electric power as the rate of doing work. We can say that rate of doing work is called as electric power, and you can state like this also, that an electric power is a measure of the rate of electrical energy transfer, that is the work done here, by an electric circuit per unit time. So we can come to the conclusion, and we can derive the formula based on this. So here you have this P is equal to V into I, where P is power, V is the potential difference, and I is the current. And we can calculate power by this equation also. P is equal to I square R, where P is power, I is current, and R is the resistance. And we can calculate by this equation also. P is equal to V square by R, where R is the resistance and V is the potential difference. And then we can have this also. P is equal to E by T. So energy used or consumed per unit time, and P is equal to W by T, and it's work done by the time. So we can use these equations to solve the problems, and these are very important that you should know. And then coming to the next topic, so we will learn about the resistors in series. So there are two methods of connecting resistors that you have to learn this year. So that is resistors in series. You learn that how resistors will be connected in series, and the other method is resistors in parallel. So after learning about resistance series, we will go to resistors in parallel. So here this RS is there. So S stands for series and R is resistance. So resistance, total resistance we get when they are connected in series. So now let's have a look on this. A series circuit is a circuit in which resistors are arranged in a chain so that the current has only one path to take. So this is just to explain you what the meaning of the resistors in series. So these resistors are connected end to end. So one end to the other end of the resistor, the remaining end to the one end of the next resistor, and the end which is remaining is connected to the battery. So here if you look at this diagram here, this R1 and this R2 and this R3, and these ends are connected to the potential difference, that's the battery here, and here in the diagram it is shown that this is 12 volts, and the value of this R1 is 10 ohms, and here value of R2 is 20 ohms, and value of R3 is 30 ohms. This is also the way we can connect resistors in series. Now coming to the next diagram. So this is what is given in the textbook and that you have to write when it is asked in examination. So here this is R1, R2 and R3. These resistors, three resistors are connected in series. This type of connection is called as series connection. And here one end is connected and the other one to the battery. So here this is the battery, the other to the ends of the resistors are connected to the battery, and here this is the ammeter, and ammeter is connected in series. This is called as resistors in series. And look at this another one more device, that is V. What is V? Here V is the voltmeter, which shows the potential difference across the ends. So therefore this voltmeter will be connected in parallel with these resistors. So it should be connected in parallel because we are going to measure the potential difference across the ends of the conductors. So in this ammeter we are going to measure the current, therefore it should be in series. So this is the diagram wherein you will learn that how resistors will be connected in series. I am coming to the formula. So this formula RS, S stands for series, RS is equal to R1 plus R2 plus R3. R1 plus R2 plus R3. So if you add these resistors in series, the resistances, take for example here R1 is 10 and R2 is 20 and R3 is 30 is given in the first diagram. So to find out the total resistance, 10 plus 20 plus 30, it will give you 60 ohms is the total resistance when resistors are connected in series. So this is RS. And here the third diagram is also, you can draw like this also, when there will be 5 resistors. So resistor 1, resistor 2, resistor 3, resistor 4 and 5, these will be connected end to end. This type of connection is called as series connection, and we connected to A and B here across the battery, that is which gives potential difference. So these three diagrams are there to show you that how resistors will be connected in series. Now next let us go on to the next point, that is resistors in parallel. So it can be denoted by the letter Rp. Here P stands for parallel and R is for total resistance. Now let us learn what is this resistors in parallel. Resistors in parallel here in this, a circuit is said to be connected in parallel when the voltage is same across the resistors. Now look at the diagrams. So here how these resistors R1, R2 and R3 are connected across a battery here. And coming to the next second diagram, this is what you have to write in the examination also, and there was an explanation. And here see, these are the three resistors. You can see these three resistors R1, R2 and R3. So one end of all these are connected towards one side, let us call it as X, and the other ends of these resistors will be connected together, let us call it as Y. So this type of connection is called as parallel connection, resistors in parallel, and this X and Y are connected to a battery, and we have a plug key there and an ammeter. So as in series connection also we have learned the voltmeter, this V is voltmeter, it is connected in parallel along with those resistors, whereas ammeter is connected in series. So it should be in series connection and that will be in the parallel connection, and you will get that potential difference there. And here we can measure how much current is flowing through the circuit, and this arrow mark shows how the current flows. This arrow mark shows the flow of electric current. And here going to the next diagram, so here two resistors are there, and these two resistors also will be connected in this manner, and these two ends together at A, and the other two ends will be towards the other side, that is B, and these A and B are connected to a cell with the potential difference V. This positive terminal, longer one, and shorter one is the negative terminal, and the current is flowing in this manner. So this is about the parallel connection. And here the formula to calculate is not like as in series connection, but here reciprocals are there. So 1 by Rp, that is P is parallel, resistors in parallel. So 1 by Rp is equal to 1 by R1 plus 1 by R2 plus 1 by R3. So if you take the value as 2 ohms, 3 ohms, 4 ohms, we get the reciprocals and take the LCM and find out the value, and then you have to convert it. So if you whatever you get, if it is in fraction form, just reciprocal of it will give the resistance, total resistance of the resistors which are connected in parallel. So now let's stop here because the remaining important questions I will discuss and I will tell you in the next video. So all the best, work hard and do well.